So the curious thing about this question is when you read the question, which is very important, obviously, it does state to you how many litres of oil can be stored in this drum. And prior in the examples, and some of the examples, and further up, they let you know that 1 kilolitre equals 1 cubic metre. All right, but kilolitres aren't necessarily what we're after. We're after litres, okay? And so we might have to scroll a little bit further up to find a conversion thing. Now, are you meant to know the conversion things, charts? No, you're not. They'll be given to you, all right? But what you do need to know is the process of achieving the result. Okay. So, how many litres can be stored in the drum? What are we thinking about when we're thinking about the litres within it? We're thinking about its capacity or volume to hold that fluid. Okay. Now, the volume of the tank above, which is a very similar shape, no doubt, you can see that, is the area of the base times by the height. Okay, so we would apply the same principle. And I'll just scroll up a little bit. And remove that. So we're talking about volume equals area of base times by our height. Okay, so the area of our base, what shape is our base? That's the question we should ask ourselves, and the shape of the base is a circle, and the area formula for a circle is pi r squared. Pi r squared times by h. Okay. The radius, therefore, is how many centimetres, Ryan?
Half 57.
Excellent. Half 57. That's half of 57, which is 28.5. 28.5 all squared multiplied by the height. Just because it's on the ground, it doesn't mean to say that's not the height. You know, if we rotated this, you've got a base of 57 and your drum of height 85. Okay, so just manipulate the diagram to serve your needs, basically. So the height therefore is 85. Okay, now what solution does that bring us, Luke?
What do you mean by solution?
Okay, what answer does this give me? Pi times 28.5 all squared times by 85.
This is a very big number. Can I just call each number?
Yep.
1, 2, 6, 8, 9, 9.48.
126,899 cubic centimetres.
Oh, 216, sorry.
216 here?
Yeah.
Yep. Now, Ryan, a quick thing I can see you doing is copying this down as you go, which is okay. My question is, will you understand it? All right. So 216,899 cubic centimetres. But the question says, it doesn't say how many cubic centimetres, it says how many litres. Okay. So if we go back up,
Yep. Times that by 1,000.
why 1,000?
Well, when you get the kilometres, times that kilolitres times 1,000 equals. Oh, yeah. Times.
You on the right track? Yep. Yep. Okay, good. So what you've worked back with, we scroll back and we go, well, hang on a minute. 1 litre equals 1,000 cubic centimetres. We have 216,000 cubic centimetres. So if we were to divide that by 1,000, 1, 2, 3, we get 216.899 litres. Okay? Approximately, that is 217 litres of oil will be contained in that. So it's about working with things like this, doing multiple applications of what you know. You know that it's area of base times by the height, and therefore you then need to work with this. The biggest issue some of us have is saying, well, if 1 litre equals 1,000 centimetres, just as you did, I think, Georgie, you said, oh, then we have to times that by 1,000. Yeah. Not enough of us understand we need to divide that. Okay? If we had 2,000, we'd have 2 litres, and so it'd go. Alright? 2,000 divided by 1,000 gives us 2, and that's what we need to get into our headset, our psyche a bit better.
Yeah, I've just been doing something different.
Yeah, I know you weren't completely with us, but it's not an uncommon thing that our class does.
Question 1 and 2.
So what we're looking at, Beth, is the fact that any volume of a shape which has the same ends, that is, they don't come together like a pyramid, they don't come together at a peak, those with the same shaped ends, which are these, they're called prisms, yeah? Now, any prism has the area of the base, or the area of the cross-section, times by the height. Okay, so if we look here, sorry. So these are all prisms, okay? This is a prism because it's got the same face there as it has there, alright? A pyramid is different, of course. That may have a rectangular base, but it comes together as a peak above the base. Alright, so that's your pyramid. These are your prisms, because that's there and that's there. There's no peak there. Alright? And so when we're calculating the area, say, of the volume, sorry, of this one, we're doing the area of the base times by the height. Okay? So the area of the base, we say to ourselves, what shape is our base? Well, here it's a triangle, so we'd have to do half base times height. Here it's a circle, so we're going to do pi r squared. Alright. So we're doing pi r squared times by the height, r being 1.5 because it's just the radius. Tell me if I'm going too fast. So we're pi times 1.5 all squared times by the height, and the height is this distance, which is 5 metres. Okay? Now if we were to calculate that on our calculator, that would give us our volume. That's what we're looking at there. Okay? Now if I flip to your question, these shapes here, they're saving you from doing Pythagoras' theorem, because we'd have to, here, for example, it's half base times height, we'd have to do, well, what's our height of that triangle? We'd have to make a right angle there, and then we'd have to know that, and we'd have to know that, and so it would go. What they're telling you, here's the area. They're giving it for you. Okay? They're asking you, find the volume of the following solids. So you say to yourself, are they prisms or are they pyramids? They're prisms because they don't come to a peak above it. Okay? Pyramids come to a peak above it. Okay? We've been through that. These are prisms because that shape is the same as that shape. Okay, what's the area of the base? Well, the area of the base, it's still the same formula, yeah? Area of base times by the height. Volume equals, in A, the area of the base was 12, times by the height, which is 5, and we know that 12 fives are 60. So we have 60 cubic centimetres there. That's the volume of that shape. Okay. This one here, we could work out the pentagonal area formula. We could do that. We don't have to, they give it to you. They're asking for the volume. Yes, it is a prism, not a pyramid. It's a prism. Got to remember that. So I use this formula. area of base times by my height. Okay? So with this one here, I would be saying they're asking find the volume of that concrete. I'd be trying to look at it like this. Okay, and so here you have a shape, and here you have the same shape. So that must be, again, it must be a prism. And the volume is area of base times by your height. Area of your base, what shape have I got? I've got a rectangle. So the formula, length times width times by height. Length times width, 1.5 times 1.2 times by the height. Don't worry about doing it, that's all right. Then I'm looking at this shape, and I've got to try and find the volume of that. Now, if I was to continue this across here, what shape would I have? I would have a rectangular prism, wouldn't I? How much have you got? Absolutely, good stuff. So I'd follow a similar process, and I'd multiply it by half. That would give you the volume of this in here, and then I'd add that to whatever you get there. Does that make sense?